in this question, we have a helium nucleus being moved within the E field. Okay, so it's moved from point X to some point, let's call this point Z, okay, and then to Y. So what's happening in the process, right, is that when you go from X to Z, you're actually, right, moving it from a certain potential, equipotential line, let's call this V1, to another equipotential line, which is V2. But, right, Z is actually on the same equipotential line as Y. How do we see so? Because all these equipotential lines, right, are perpendicular to the E field. Therefore, right, Z and Y must be on the same equipotential line. Which means, right, no work will be done when you move the charge from Z to Y, okay? But work is done from X to Z. Therefore, right, that is what we want to find, okay? We want to find what is the work done by E field, and that will be equals to the force, okay? No, sorry. In this case, right, we'll just take the Q times the delta V, okay? The potential difference between these two lines. How do we find delta V? We know the E field. E field is delta V over delta D for uniform field. Okay. Then we want to find delta V, right? We can take E times of delta D. So put that into the equation. Here we have 2 times 1.6 times 10 to the power of minus 19 times the E, which is 5.0 times the delta D. In this case, right, is the 3.0 meter. Okay, so the numbers here, right, you see you have a 2 times 1.6. This gives you 3.2. Here you have a 1.5. Okay, I mean times 10 to the power of 1. Okay, so multiplying them together, right, 1.5 times of 3.2 gives you 48. Okay, 4.8. So answer must be B.